Astronomy is amazing, and most people have heard about other pretty habitable planets outside our solar system. In fact, any planet that is not a part of our solar system is considered an exoplanet. However, for a few hundred years, we were never able to detect these planets because the stars in the sky outshone them. In this video, we're going to break down the genius way in which astronomers started to find exoplanets. Okay, so for over 1,000 years, we never knew that any other planets outside our solar system existed because we were never able to see them. If you look into the sky, you would never be able to see an exoplanet, but you would be able to see the stars. In 1995, researchers from the University of Geneva realized that if the star was the only thing they could observe with precision, they could determine the planet's effects on the star in two ways. In a solar eclipse, the luminosity of the sun is blocked by the moon, and in the same way, when the planet is between our line of sight and the star's luminosity drops for a bit, showing us that there is something orbiting the star, helping us find out the exoplanet. This is a way in which the researchers found the first exoplanet and won the Nobel Prize. Okay, before we get into the second method, I want to tell you guys something. Planets don't orbit around the star. And before you start screaming your minds out, let me explain. Since the planets and the star both have large gravitational forces, they pull on each other, and they both orbit what's known as the barycenter, which is the center of their masses. Now, this shows that the star is affected by the exoplanet's gravity, and so it moves and its radial velocity changes. When this radial velocity changes, the starlight emitted by the star changes its spectral lines. This basically means that when it's closer to the Earth, it emits bluer light, and when it's farther, it emits redder light. But these changes are super small and can only be detected by a super stable spectrograph. Now, in the present, however, we're able to find exoplanets through direct imaging and other more innovative ways. None of this, however, would have been possible without the help of Michael Mayer and Didier Queloz from the University of Geneva, and I hope that I said that right. So I would like to thank them here for helping us find out more about our universe. When we observe planets and stars through our telescopes, how are we able to tell what they are made of? This is an important question in astronomy, and the answer is actually pretty satisfying. So we have to go to chemistry. In chemistry, we learn about spectroscopy. This is a method in which we find the emission and absorption lines of chemicals with a spectrograph. Each element has a characteristic graph. Okay, well, how does this graph help us? Well, when we observe the starlight from a star, we can find out its emission or absorption graph. With this graph, we can match the lines on the graph to those of the elements and find out what they are made of. For example, the hydrogen line dominates in stars, showing us that a large percent of a star is made up of hydrogen. This is how we find stuff out for stars. But what about exoplanets? How do we find out what they're made of? It sounds impossible. Well, that's where indirect methods help us. First of all, we can measure the radius of a planet from how much luminosity it blocks while passing around a star. Then, we can find the mass from how much the star wobbles due to the planet's gravity. In this way, we have the mass and the volume, which means we can find the density. But why would we need that? Well, if the planet has a high density, it's probably rocky. If the density is low, it's a gas planet. But if it's intermediate, we might be able to find worlds made only up of water. How cool is that? Okay, so now we know about the type of planet, but how can we know what it's made out of? Now comes indirect spectroscopy. When the planet passes between our line of sight and the star, its emission is also recorded, and we can find the composition of the atmosphere by removing the emission spectra of the star and just looking at the emission spectrum of the planet. In this genius way, we're able to find sort of habitable planets, amazing stars, and beautiful creations of the universe. I hope you guys found this video helpful. If so, make sure to like and subscribe and leave a comment about what you enjoyed and what I can improve. Stay curious like a child, the world needs more of it. Bye.